Hello, today we're going to be doing 2.4 in finite notes. We're going to be working with matrices. Looking at the top of page 51 of your notes, students will be able to, after this lesson, to find the dimensions of a matrix, find the sum of two matrices, work with properties of matrices, find the difference of two matrices, and find scalar multiples of a matrix. I'm very unsure right now without being here to talk to you about if you had matrices in Algebra 2. There's a possibility that I thought that was being put back in the curriculum, so this may be a little bit of review for you. So if so, then just work through them very quickly. Just to review a little bit of terminology. What is a matrix? A matrix is just a rectangular array of numbers. It doesn't have to be numbers, it could just be data, it could be anything, but it would look something like this: 1, 2, 3, 4, 5, 6. There's a matrix. The dimensions of a matrix is, you have to remember, go rows by columns, M by N, where M is a number of rows, N is a number of columns. This last matrix is a 2 by 3 matrix, 2 rows, 3 columns. A square matrix will have the same number of rows and columns, so a square matrix 1, 2, 3, 4. The dimensions of that would be a 2 by 2, 2 rows, 2 columns. A row matrix will only have a row, 1, 2, 3. There's a row matrix. That is a 1 by 3 matrix. That's the dimensions of that. A column matrix only has one column, 1, 2, 3. That is actually a 3 by 1 matrix, 3 rows, 1 column. Okay, equality of matrices. Two matrices will be equal if, number 1, they have the same dimensions and corresponding entries are equal. And the last one, a zero matrix, just has all zeros. We don't have those very often, but I just thought I'd add it in there. Okay, example 1. I have two matrices set equal to each other. I need to find x, y, and z. Now, if these are equal, they have to have the same dimensions. Notice this is a 2 by 2 matrix on the left side and a 2 by 2 matrix on the right side. So yes, they have the same dimensions. So now we can set corresponding parts equal to each other. I have there x plus y equal to 6. I have negative 2 in the same position as x minus y. I have 4 equal to 4 right here. 4 is equal to 4. That's true. And then I have 10 equal to z. So I know right away z is equal to 10. Circle that one. Now the other two, x and y, looks like I get to do elimination. 2x, the y's cancel, equal to 4. Therefore x is 2. Plugging back into the original, the first one, x plus y equals 6, x is 2, so y is going to be 4. So there we go. I found x, y, and z. Example 2, we're going to be doing addition of matrices here. So if I want to add two matrices, I have to double check, do they have the same dimensions? If they don't have the same dimensions, then just put not possible and then you're done. This first matrix has 2 rows and 3 columns. The second matrix has 2 rows and 3 columns. So they're each a 2 by 3 matrix, so yes, we can add those two together. So now what I do is I just add corresponding parts together. I add 23 to the negative 2 to get a 21. I add 16 and the negative 8 to get 8. I add 10 to the 1 to get 11. Now working on the bottom row down here, I add 7 and the 10 to get 17. I add 9 and the 3 to get 12. 11 plus 0 is 11. So there's my ending matrix right there. Boom, we're done. Okay, now subtraction. We subtract the same way. So I can take 2, well, first of all, this is a 2 by 2 matrix, this is a 2 by 2 matrix. Yes, they're the same dimensions, so yes, we can subtract. I can take 2 minus 8 to get a negative 6, 4 minus 9 to get a negative 5, 3 minus 0 to get 3, and negative 4 minus 7 to get negative 11. So you can keep it straight that way. Now another option, 2, 4, 3, negative 4 minus 8, 9, 0, 7 If you kind of forget about subtracting, what you can also do is change that to addition and change all the signs in the second matrix to the opposite of what they were. So you can distribute that negative and then just think about adding the two matrices. If that's better for you, you get the same thing. So another option there for example 3. Okay, on the next page we have our properties of matrices. When we're adding matrices, the commutative property holds as well as the associative property. For matrix addition, that one holds. Commutative property just tells you you can add the two matrices in any order and it still works out. Associative property says you can change the grouping of what you add together and it still is the same. Additive inverse property, if you add A, matrix A, with its opposite, you're going to get 0, which kind of makes sense. Scalar multiplication, you can multiply a matrix times everything. And there is some properties of scalar multiplication listed there in your note guide, so make sure that you look at those. We're going to apply those properties here in examples 4 through 6. So if you look here, I have 2a minus 3c in example 4. Now, I want to make sure that I don't make any mistakes, so I'm going to actually write 2 times my matrix A. So I'm going to write down my matrix A minus 3 times my matrix C, negative 3, 0, 5, 2, 1, 3. Sometimes we're whipping through these addition subtraction ones real quick and we just make careless errors. So I try to eliminate those by kind of writing things down here. Okay, the first thing I'm going to do is multiply everything in that first matrix by 2. So I get 4, negative 6, 8, 0, 4, and 2. Now instead of multiplying by 3, I'm actually going to multiply everything by negative 3. So I'm going to change that minus 3 to be plus a negative 3. So I'm now going to make mine an addition problem and multiply everything in the second matrix by negative 3. So I get 9, 0, negative 15, negative 6, negative 3, negative 9. Now I'm ready to add the two matrices together. 9 plus 4 is 13, negative 6, 8 plus negative 15 is negative 7, 0 plus negative 6 is negative 6, 4 minus 3 is 1, 2 and a negative 9 is negative 7. There we go. There's my answer. Okay, moving on to example 5. I'm going to take a plus b and then I'm going to add that to 3 times c. So I'm going to physically write down 2, negative 3, 4, 0, 2, 1. 1, negative 2, 0, 5, 1, 2. And double check and make sure I wrote those down right. Don't want to make a mistake on that. Now those two are going to be added together. And then I'm going to add to that 3 times c, matrix C, negative 3, 0, 5, 2, 1, 3. Now again, you don't have to be writing these matrices down if you can get by with just doing a little mental math. I understand that. Okay, so I'm going to add these two matrices together, double checking are the dimensions the same. This is a 2 by 3, this is a 2 by 3, so yes, we're okay. Okay, so I'm going to add those matrices together to get 3, negative 5, 4, 5, 3, 3. Now I'm going to take 3 times everything in that second matrix to get negative 9, 0, 15, 6, 3, 9. Okay, now I'm ready to add those two together to get negative 6, negative 5, 19, 11, 6, and 12. I don't think I made any mistakes, so I think we're good. Okay, now, next one, example 6. 2 times A minus 5 times the quantity B plus C. Do me a favor and pause the video. I'd like for you to try this one on your own, and then, or if you want to work with your partner, cross-AL partner, that would be great as well. But I do want you to try this one before you check back with me. So if you can pause the video and then check back with me as soon as everybody's done, and I'll have the answer for you. Okay, coming back here, I actually wrote out 2 times my A, which is 2, negative 3, 4, 0, 2, and 1, minus 5 times big brackets B plus C. So I had in the big brackets my matrix. I probably should do that a different color. 1, negative 2, 0, 5, 1, and 2, plus C, which is negative 3, 0, 5, 2, 1, and 3. Big matrix. Okay, so what I did then was I multiplied 2 times everything in that first matrix, so I got 4, negative 6, 8, 0, 4, and 2. Minus 5, I added those two matrices together, so adding those two blue matrices together, I got negative 2, negative 2, 5, 7, 2, 5. Double checking those. Yes. Okay. Now, what I'm going to do then is I'm just going to do one step at a time. I'm going to multiply the second equation. I'm going to change that to plus a negative 5. So that second matrix is going to be multiplied by negative 5. First matrix stays the same. Adding negative 5 times everything, it's going to be a positive 10, negative 25, negative 35, negative 10, negative 25. Now I'm ready to add those two matrices together. Final answer, 14, 4, negative 17, negative 35, negative 6, negative 23. There it is. Thank you very much. Have a great day.